The heart of a gas centrifuge is a long hollow cylinder called the rotor. Rotors are between 1 meter and 4 meters long and between 10 and 30 centimeters in diameter. Either end of the rotor is capped. The rotors are always mounted vertically so they won't sag under their own weight. The rotor is held in place by bearings at the top and bottom. Just below the rotor lie magnetic coils, and the coils and the bottom of the rotor together form an electric motor. When power is supplied to the coils, the rotor begins to turn, and it turns very, very fast. The rotor may be turning tens of thousands of times per minute. The outside of the rotor can be moving faster than the speed of sound. To reduce the friction with the air, and to protect the surroundings in case the rotor flies apart, each centrifuge rotates inside of a steel casing. Most of the air between the casing and the centrifuge is pumped out, leaving a near vacuum. The rotor is spinning so fast that the g-forces near the outside can be 1,000,000 times stronger than gravity. This force can be used to separate mixtures of heavy and light materials, like separating cream from milk. If some uranium hexafluoride gas is put into the rotor, the concentration of the slightly heavier uranium-238 will be slightly increased near the rim, and the concentration of the lighter uranium-235 will be slightly increased near the center of the rotor. This effect is tiny, but there's a trick to greatly increase the degree of separation. If one end of a pan of water is heated, the water there rises and cooler water comes in to replace it, setting up a convection current. The same thing will happen if one end of the centrifuge is heated. Keep in mind that up in this case is toward the center of the centrifuge and down is toward the rim. Heating one end of the centrifuge creates a convection current. While the general flow of the gas is along the wall toward the hot end and along the center toward the cool end, individual molecules of uranium hexafluoride are actually bouncing between the two flows, sometimes going one way, sometimes another, but in general, the heavier uranium-238 will spend a little bit more time along the wall, being pushed along in that direction, and a little less time along the center, being pushed along in that direction. The slightly lighter uranium-235 will be just the opposite, spending a little more time being swept along the center and a little less time being swept along the wall. This means that the heavy and light uranium separates not between the rim and the center, but between one end and the other, with the heavy uranium-238 collecting at the warm end and the lighter uranium-235 collecting at the cool end. Tubes running along the center of the centrifuge pull out the gas that is enriched in uranium-235. Of course, gas taken from the opposite end is now slightly depleted in uranium-235.